That's all
Maybe
it
we
is.
don't.
It's not.
Just something
What?
like,
But
Not
doesn't
you.
the other equation say that like it's farther away?
He's so
Super
I
accepted.
don't know. He's like,
Let him
Why don't we do it one
explain.
concept at a time?
He's always
Okay.
like mid class.
Time is
Yeah.
fast.
So,
I messed it up. I have the right answer.
okay. So does everybody agree if you have a positive charge in the middle,
Yeah.
you can have positive voltage lines that go out from that?
Yeah.
disagree.
Everybody cool with that?
Yeah.
And as you go away, what's going to happen to the value of the voltage line?
Decreases.
It's going to get bigger, right?
Yeah.
Everybody cool with that? It's going to get bigger.
What was the question again?
Or, I'm lost.
I'm going, don't worry about the electron, just worry about these positive charges.
Yeah.
You said that it would get bigger as you go out.
Just
Okay,
Okay.
confused.
so,
Where's this going?
okay.
Just have to trust.
So I got three positive charges right here in the middle.
Yes.
So when I plot the lines of equal potential and I go further out, what happens to the value of the line?
Small.
They get
Smaller.
smaller.
Yeah.
That's what you.
So if I go
So why did you
from
say
here
what?
out, okay,
that? Yes.
what's going to be the sign of delta V?
Negativo.
Negative.
Because you have the final minus, like you're going to have 5 minus 13, whatever it is.
Yeah.
Delta V is going to be a negative value.
See.
What's this?
See.
Gavin.
Okay. Now, if it's an electron,
Yes. Positive delta U.
if it's an electron,
Yeah. Negative Q.
and delta U equals Q delta V,
Yeah.
Negative.
Yeah.
Negative.
right?
Positivo.
So I'm going to have a negative Q times a negative delta V, which is going to create a
Positive.
delta U.
Cierto.
Okay?
See.
That's confusing, bro. So it increases.
I understand.
Okay? So, since delta U is positive,
Well,
okay? Since delta U is positive,
Yes.
yeah.
what's going to happen to the value of ooey?
It increases.
It
Big.
increases.
Big.
Ooh. Okay?
I thought you asked about the voltage.
I was talking.
You told us not
Say
to
with
worry
me.
about the electron?
No. Now I am going to worry. I was talking just the delta
I'm
V
not gonna worry
itself
about it,
is
but
dependent
actually I
upon
need
the
to worry
charge.
about it now.
Okay? Now,
You know,
if this had been a proton,
Negative delta U.
then delta U would be a
Negative times
positive
positive.
value. Now, just back up the bus.
What?
Back up the bus.
What?
Back up the bus.
Bus ran over.
Literally.
Let's go back to
Just
this
walk
being
out.
an electron.
Get a raise for
Okay?
I missed the bus, bro.
If this is an electron, is it attracted to nucleus?
Of course.
Yes, it is. So, if you were to push that electron away,
Uh-huh.
okay?
See.
You're to push the electron away, right? You're pushing it away,
Si, senor.
okay? So if you let go of it, what would happen to the velocity?
Increase.
It would
Bigger.
increase.
Because it's like,
Yeah.
So as this thing goes away, as this thing moves away,
Yeah.
right?
Yeah.
Is it going to be slowing down or speeding up? Slowing down because of the fact that it wants to go back towards it.
yes.
Yes.
Yeah.
Indeed.
Because you go
Now-
back, it goes.
In contrast to that, look at number 4. Okay? The question right above. So number 4 is moving in a circle. So how much work is done on the electron as it moves from I to F?
Oh my god.
Because
How much
because
is
the distance
it
between the
as it
two
goes
stays the
from
same.
I to
Zero.
F?
Radius is the
Initial,
same.
final.
No work. Because you're not moving across a voltage gradient. Radius is the same. And the radius stays the same. So that's somewhat analogous to
FR.
The
solar system.
I heard you first.
Where are you getting these answers from?
What are you saying?
Okay, Mr. Burke.
Circle.
Okay. So 4A is like this.
Stop.
Am I exerting a force on the stopper?
Yes.
Yes.
Literally no.
Bruh.
His mommy puts back.
That's on you.
Wait, what do you do?
Wait, what do you do?
Mommy leave it back.
So
You forgot to leave the notes. Yo, I didn't get to eat lunch. Okay, my bad.
then don't put fish on his shoulder. Don't sit there and whine about not eating lunch and then you put food on his shoulder.
Read the Bible and he's trying to spread some love.
Valid?
You get this as policy.
Okay.
What type of rage
So-
talking about in the Bible, bro?
As this goes around, am I doing work?
No.
Oh,
No.
sorry.
No.
Listen, I'll explain why it's not. It's because the radius is the same. It cancels out. There's no distance.
No, really?
Oh my god.
I got this.
Obviously.
I got this. This guy
His answer is wrong.
Big
No
No change in radius.
There's no movement in the direction of the force.
Oh God, I
Change
was
it to the
in
force.
physics honors.
There's force acting on the rubber stopper.
Yes.
Yes. Which direction is the force acting?
Inward.
Inward. Is there movement in that direction?
No.
No. So this now, in analogous, this would be maintaining a constant line of voltage.
See.
Okay? Right?
Yeah.
So that would have a certain amount of kinetic energy per unit of mass, if you wanted to think of it that way. Okay? So on A, there's two reasons why no work is done. You're going to be traveling in a line of constant voltage. There's no voltage, there's no change in voltage. You have voltage, there's no change in voltage. Okay? And there's no displacement in the direction. So you got that. Now, when you get to B, it says how much does the electrical potential energy change as the electron moves from I to F? 0. Why?
If there's no work, there's no change in radius.
Beautiful.
The radius is.
Or if you look at delta U equaling Q delta V, if it moves in a perfectly circular system,
Yeah.
that's meant you're traveling in a line of equal voltage.
Yes.
So if there's no change in voltage, your delta V is
0.
so delta U is
0.
Okay? That makes sense.
Yeah.
Okay. Now, then when you get to C, is the electron speed at F greater than, less than, or equal to the speed at I?
Stays the same.
Equal.
It's the same, because if there's no change in ooey, there's no change in
Cooey.
kinetic.
What the heck is cookie?
And then, are your answers A, B, and C consistent with each other?
Yeah.
Yes, because if there's no work, there's no change in energy, and there's no change in velocity. Now, if you compare that to number 5, 5 work is going to be done because you're going to cross lines of voltage. Okay? You have an electron that's moving away from that positive charge. So therefore, you're going to have changes in voltage and you're going to have work that's done. What, Big Mike?
On number 1,
No, I was about to go there
is
too.
my answer greater than or less than 200?
What?
Okay.
This guy.
On the question or problem?
On question number
Okay. Let's talk about question number 1. Moving a 10 nanocoulomb charge, point A to point B, okay? What would be the potential at point B if a 20 nanocoulomb charge were moved from A to B? Okay? Now, this boils down to one word, okay? And that's the potential, okay? It's the potential. So, let me go back to this graph. Okay? Okay? So we got these two positive charges. Okay? Right? We got these two positive charges. So here's the question that basically you're talking about. And this is why it's so important that you pay attention to the vocabulary. So it's asking what would be the potential at B if you had used a 20 nanocoulomb charge to move it. Okay? So here's what you have to look at. If you're talking about the 10 versus the 20, and that's what's out here in the field, it's what's experiencing the field. Okay? It's what's experiencing the field. Is what I put out here, let's just plot this. And there's like 26, and there's, I don't know, okay? All right. What determines that change in voltage from 30.6 to 7.9? What determines that change in voltage, which is the potential? And? The source. The source. The source.
See.
The source is what determines those lines of voltage. True?
Yes.
Oh, so the source is staying the same.
Then nothing changes.
Then nothing changes.
Ooh.
Oh.
On which one?
One.
On number one.
It's 0?
No.
Use next one.
No,
It's-
150.
no,
It's
that's
not
not
zero,
nothing
it
changed.
just
Am I right?
stays the same at
I had
150.
that.
Yeah.
Right
Well,
down.
did you ask the question?
Okay?
No, they might.
Now, here's how it would have been different. If it had said what would have happened to the change in UI, or what would have happened to the work, that would have been dependent upon the 10 or the 20 nanocoulomb chart. Okay? That would have altered it. But since it's just asking about the potential, the charge doesn't matter. What's experiencing it. The only thing that matters is what's at the center and what's creating the voltage. Okay?
Oh, yeah.
Yeah.
Do I have to have an explanation? It doesn't ask for that. But Nathan and Shay will say I do.
When in doubt,
Write it out.
write it out.
Ooh, he's
Bars,
bars.
bars.
Okay.
Hey, I'm not in doubt anymore.
You're gonna.
Your answer to problem 2 should be, if you're in nanocoulombs, around 10.
Oh, okay.
That
Yeah.
Bars do cool. Where are we?
No, you got it.
literally-
Like times 10
Right there.
megabits.
What's
Oh, I like that. I like that.
Yo, that was a bad throw, bro.
I know.
Sir,
Just give me like a.
Oh, one more time.
It's where your
or
anions
like, is
go.
it like negative or positive? Wait, what did you say?
Anions. What are you talking about anions?
Wait, what did you say?
Wait, where do the
Rebecca?
anions go?
Yeah. What's
Mr.
the
Richard.
name?
What did he say?
Back
Where's the
question.
anions?
Bro,
Where the anions go?
he just said that
It could
in
also be
last
positive.
class.
So what's that mean
On
for
4,
me?
could it be negative? It could also be added.
Nathan, do I?
Now, on problem number 4, your answer should involve a 4.
Wait,
That's
negative?
crazy.
I'm just saying,
Yeah.
your answer to 4 should involve a 4.
Anion. Anion.
I'm just saying. You figured it out from there.
I had my name.
Wait, guys.
Let's go like plus or minus.
Hey, guys, get
Plus or minus.
I did not understand what
Mr. Berg.
It does involve a 3.
Mr. Berg.
What if I put like,
Mr. Berg.
what if I
I
put
didn't
like
get
after
one of
that?
Can I go to the room of the porcelain throne?
Huh?
He's going to the bathroom.
Can I go to the bathroom? Hey, man.
Yeah, just go to the
Okay, are we
And
good?
water.
I knew this was going to take a long time to explain. Okay, everybody got it?
What's your favorite Girl Scout?
Is it positive or negative?
Huh?
What's your favorite Girl Scout?
10 minutes.
Awesome.
You ask, I give an answer, then you give a judging response.
Didn't you want one from him the other day?
I'm just saying, like, lemonade is respect.
You don't
get a valid
okay,
anymore.
why did you even ask?
Well, because I was curious.
But then you go, that's not right. You judge my answer. If you potentially are not gonna like the answer, don't ask the question.
Well, it's not that I don't like the answer. It's just not
No,
try.
you didn't like the answer. If you liked the answer, you would have been, Mr. Burkamp, that's spot on, good answer.
Well, I'm like, Thin Mints is good.
See, you don't like the answer.
Thin Mints are good.
No, I like.
I agree with him.
I like.
Because there's a but coming up in this.
But
On the other hand,
however, semicolon.
although in the event they're better than oatmeal raisins. Oh, I love oatmeal raisins. Yeah.
Alright, guys.
Anything is a word I can use to add.
Yes, 2 and 4 negative.
Or can't do me? Stop the camera. Stop it.